Welcome to my talk about data-driven software development, or the quest for the intelligent machine that manages software projects. Thanks for coming. I'm Stefan Richter. I'm an engineer and computer scientist. Wrote my first program in 1983 on an Apple II with UCSD Pascal, and from that moment I knew that I want to do this the whole rest of my life, writing programs. And so the first 15 years I wrote lots of C programs and 4GL programs, which you might not know. At that time you had lots of programming languages from specialized vendors, which is not the case anymore that much. And the last 15 years, after I founded code.talks Technologies, my company, I did a lot of Java, and Java was actually really cool in 1998, 1997, and Python, Common Lisp, lots of Clojure and JavaScript. To Clojure I come also later. And my current favorite is Go. And also I have a talk tomorrow where I will also do some live coding in Go. And I also have a Code Week day on Thursday, I guess. Yes, on Thursday. And so maybe there are seats open and you can maybe participate, and we'll do some, so you would do learning Go by live coding, you can follow my code, and then we build stuff together that day. In the evening there will be a Rust meetup, so we have the Gophers there the whole day, hacking together, and then in the evening there's a Rust meetup with a cool presentation about that. We will have a barbecue, so yeah, check out if there are seats left and be there. Okay, my company, code.talks Technologies, we are sponsoring this event, and actually I like the conference very much. Normally, I traveled at least 1 or 2 times a year to the US to go to the cool conferences, because the conferences here in Germany were always very boring. But this changed here. I think the location is very nice, and also the guys are really trying to do the best thing to have good talks here and a good community. So my company, code.talks, we are sponsoring this because we want to support this, especially in Hamburg. And I founded my company in 1999, and we are building large-scale internet systems since then. We have 90% developers, so we were always from the beginning a complete developer shop. So it is founded by programmers for programmers, and everybody has a degree in computer science, mathematics, physics. And we are more like a self-organizing, self-optimizing, hierarchy-free organization, but very, very well organized. So it sounds like disorder, but it's not. It's really, really cool place to work. And we work for lots of large corporations as well as for interesting startups. So last year, this was my first talk at the Code Talks at this large stage, and you can imagine it's really big, and I can almost not see you guys. I don't know how many people are here, but you see this little guy in the corner. That's me, and this is again me. So it's always amazing to be on this stage, and I always try to do something for a year to have something really interesting, an interesting project that I can push until the Code Talks conference. Last year I built a neural network system in Clojure, and this year I built a software, or we built a software in our company, and I did lots of the intelligent agent part that helps us, or that should help us, to run software projects. So maybe you all know this T-shirt. It's quite old. Go away, or I will replace you with a very small shell script. So this stuff that people often thought when they were engaging with project managers in larger corporations or in normal software projects before Agile. So because normally project management is like people sending around emails or bringing people to meetings and wasting their time. They cannot work at that time. So it's very, very difficult to, as a developer, to thrive in such an organization where lots of the organization is very chaotic. But on the other hand, you need this information to have everybody on the same page. So it's really difficult to do that. And I thought, how can we build a system that manages that for us? Actually, we are doing this since quite a long time. So I founded my company in 1999, and we were very fast in developing our own tools, and we were already having our own agile methodology at that time, much before XP or before Scrum method was widely adopted. So we built our own systems to run our own agile methods, and the first system was actually Captain Feature, which is in the upper right corner, no, in the lower right corner. So that was a system built by some of my colleagues, and we were running like stories or features over the system, and we're planning stuff. And next to it, there's a small gray thing. We actually built an editor to write concepts. And it's not like a normal editor where you have like a big piece of text, but you could have like sections of text which are like records under the hood, and you can attach metadata to them. So in that way, you could write complete documents that were looking like Word documents, but in the end, they were really data structures under the hood. And on the lowest level of the tree of the chapters, when you came to the last nodes, these were actually the stories, the features that had to be implemented, and we already attached metadata to them just to make estimations and all that. So we wrote like concepts with that, with several thousand pages, and did really cool estimations based on the data structures under the hood. So that was already a very good tool chain. We called it Captain Feature and Lieutenant Feature, and this was really good for us for working. But we were always a little bit unhappy with it. We were always like, how can we do better? And for example, how can we reduce the burden of running a project, giving everybody transparency? So in the middle, you see, for example, a diploma or master's thesis from one of my colleagues, Philip. I'm not quite sure if he's here today. In 2004, he did his master thesis about a rule-based expert system that automatically, continuously, and data-drivenly measuring the progress of software projects. It was actually written in Prolog at that time, and it was communicating with us developers over XMPP. So we had like a chat client talking to us already in 2004. Actually, this system was very difficult to change because it was based on a large Prolog program. So we didn't really use it that long, but it was an interesting experiment and tech study that we did. And then, a couple of years ago, we decided to give it a new try, and we developed what you can see on the left-hand upper side. It's called the Deadline, or it was called the Deadline. It was more like a task management system, because we first thought, okay, let's start with something simpler than software projects. It's like tasks. But we integrated there a rule-based system based on production rules and the RETI algorithm. And it was completely written in Clojure and was running on App Engine. And we did some blog posts which made us the first people ever building a large application in Clojure anyway. But we also got some little fame of it because we were running it on App Engine and how to get this running. In the lower corner, which is barely which you can barely see, it's some of the rule sets we had under the hood that were running on App Engine to run your tasks through a list of rules to check what kind of information you might need now at this point. So this was actually our history on how to make project management more intelligent, but it was very, very difficult with the existing tools to make this really work. And I think now, a couple of years later, we have much, much better tools to build complex systems like that. Not to forget, in the right upper corner, this ugly white thing was a thing where I tried to write a Captain Feature clone completely in Common Lisp using Hanschentut and Lisp macros, which was really nice, but we also never used it in production. So it was very difficult for us to get to a new level. Why not just copying the existing thing? So today I want to show you how we have built a system like that now. And just to give you a simple preview, we built two parts. One is a very, very neat, clean application, all with material design, written in React, one-pager JavaScript application, where you can really write epics and break them down into features and into stories and tasks. And it does all the estimations for you, making all the housekeeping for you. And you can really write stuff in it like Goethe. So writing really cool stories with a tool, and this is why we call it Goethe. And you can really write documents with it, but they are not documents actually under the hood. They are really interesting data structures where we can reason over. And then to communicate with the developers, we created an intelligent agent-based backend which communicates with the developers over Slack. And this is just one idea how we can communicate, but this is This is the way we are doing it now. I will show you later some demo videos. Okay, but maybe you say, we are agile, we don't need any project management anymore. But when you take a closer look at it, you see that building software in larger teams is still very, very, very difficult. Why is that? When you see like the old processes that were like in place for decades and everybody was doing it, and when I was a kid as a programmer, I was like, when I did my first project, I knew in the first moment that this is wrong, how to do software, how to build software. It had long chains of people working together. Like you see here a picture of the infamous V model. I think this is still in use in some corporations and places. You start with a requirements analysis and have you lots of documents that you write down, and they all have to have some kind of traceability from the first requirements down to the code. And then when you go up, you do the testing and unit testing and acceptance testing, and you always try to cross-check around these different levels if what you stated in the beginning is in the end really delivered. So it was really, really complicated processes with lots of different peoples and roles integrated in this process, and it makes it so difficult because so many people have to talk. Actually, the problem most of the time is not writing the code or writing the software. The problem is talking about it. And the more people and the more roles you have, the more difficult it gets. So then on the other right-hand side, on the top, you see another diagram that tries to explain how software processes should work. And you don't need to see the details to see that it's totally fucked up. It's too complicated anyway. So when we see now today's agile processes, I think everybody can see the shortcut now. We don't go through all these loops and don't have these long process chains. We try on one hand side, on the left hand side, we try to have like a product owner who cares about customer value and thinks about what kind of customer or what is the highest value I can create for the customer, gets from there the stories that the software should implement, does this together with a developer and he's writing the code or she's writing the code, and then in the end we have production software, and you don't need all these steps and discussions around all these other areas. And when you see today, like also my predecessor here on the stage from Zalando said, you cannot, when you want to have a modern software organization, you cannot just implement Scrum and have the same organization that was running these processes before, having everybody in the same place with the same organization, the same departments and everything. You really need to change the whole organization to make it work totally different, in a totally different way. So the problem is in the end, but for everybody, when you have a small team like of 3 developers or 2 developers, 1 product owner, everything seems so simple. You can just talk over the desk, and it's very, very easy to get things done and to talk about the most important things that are next on the list. But the structures are getting larger, they're getting more complicated, and they become really less easy. So in large organizations, you have to report to different units and to managers. You get communication from the organization. Maybe the importance changed, the world changed, so you need to know that. So there's much more communication needed, and not just to satisfy the reporting chain, but it's really, really important that everybody knows what is important and what is not important, what to take care first. And normally, the larger the organization gets, the more meetings you have. So people will drag you into meetings and try to get the information. What are you working on? Are we on track? Is this and is that? And so this is how normally larger management organizations try to extract information from the team, and how to extract information and find out if the project is on track. So, and it gets also more difficult when you have larger teams of software developers. Even if you cut them off in smaller teams running their own microservices stuff, somehow you still have to talk, and this takes time. So what we really need is to get the right information to the right people at the right time. Normally we might think that Agile changed the way a project is actually looking like. Actually, projects never change. They are always the same, and it doesn't matter if you do waterfall or if you do Agile. A project always has an end date. And it's predetermined before you even start developing, because the limits are money. You only have this amount of money to spend. Or the limits are you have a marketing campaign and you want to deliver before the marketing campaign because you had to buy TV spots. Or you want to deliver before Christmas because this is the biggest season for your company. So you always have an end date. It doesn't matter how you run your project. And of course, you always have a start date. And this means when do you have the team assembled that you can start. And then you maybe grow the team in some steps. So maybe you're not starting with a big team in the beginning, but you're growing this team. And then from the day you start, the past is growing and the future is shrinking. So future getting smaller, smaller, smaller. And every time and every day when you're doing project management and you try to reach this end date, you have to find out actually what is the state of the project. And this is also very important because software development is getting faster and faster and faster. That means that companies that have faster teams are better off than companies that have slower teams. So this whole system would gravitate more into faster and better, not just faster, you always have to get better, but when you deliver the same quality, of course faster is better because it provides lower cost to you. So the most important thing here is also to know that power is forced by distance, geteilt durch time, and not multiplied by time. So it doesn't matter if you measure in points or in ideal days, you always have to be fast and you have to find out if you're leaking time. So when you do project management, you're always asking yourself, are we on track? Is there anything slowing us down? And Roald Amundsen, which is the guy who reached the North Pole in 1911, says, adventure is just bad planning. And I think he must know it. But to understand what planning really is, a plan is just an assumption. So it's not like something that will stay true until the end of the project, but it's just an assumption where you can start with. And you should do the best that you can to make this assumption very, very good in the beginning. And then when you do the planning, and this is actually what you do every day, you check your assumptions every day and you adapt them every day based on your progress. And if you do this by hand, this is a very tedious work. So the first question that you ask when you're running a project is, are we on track? First thing you need is an initial plan. What do you want to achieve until when? What is the expected delivery? What is the feature set? What is the delivery date? What is actually the customer value that you want to deliver? And it's getting more interesting, for example, when you're re-implementing existing systems, like we are doing lots of times. We often get hired from corporations who have systems that are maybe in place since 10 or 15 years. And you cannot start just with a white sheet or with a blank sheet. You always have to have a lot of functionality that was built into these systems for the last 1 or 2 decades. So you really have to find out what this system does and try to make a good plan how you can achieve that in the end. So sometimes we really have projects where you have like 5,000 plus stories after analysis, and you want to put this in a plan somehow. So how do you sort that even when you have like 5,000 features? Which is the first one do you want to start with? We did, for example, develop with our tools, we did add some metadata to all the stories in the conception phase. And then we wrote programs to sort the stories in an optimal way, and then optimizing this by hand. So because normally with 5,000 stories, you cannot do this by hand at all. And then to check if you're on track, you have to check if your capacity is correct, if your forecasts are correct. Do you have the people that can do this job until the end? Actually, in our company, we have a dedicated team for that. That is just doing that. A very, very small team that is doing forecast and capacity checks. And of course, you always have to check, is your plan still correct? So I say it's a 80-20 rules, like normally 80% stays the same until the end of the project, my impression for the last 15 years at least. And 20% is uncertainty. Maybe in more complex things or in totally new things, you have maybe a higher value of uncertainty, but normally 80% are fixed. So But if you then have, because this is also much work to do this by hand, to keep track of that, do you really want to have project managers running a software project? No, because it's really difficult, because they don't understand what you're up to, and they will always ask you, what are you doing? And so this is why we don't like it, and in our company we don't have dedicated project managers, but the developers are doing it themselves. So, but we still have to keep everything on the same page. So when everybody's just sitting at their desk programming the whole day, they don't know the whole picture of the whole thing. So, and having more meetings doesn't make it better. And what I currently see now in the industry is that most companies start with implementing new processes by buying Atlassian tools, like having Confluence and Jira. But this is not really agile. It's just it's just a tool. But when you don't know how to organize your work, it will not help you. So then, of course, you have to prioritize things. You have to know, are we working on the right things? We do the Moscow method, which is like must, should, could, won't. Of course, you have to take care for the implementation order. So do you make more difficult things first, or the larger stories first? And what I also like is really when you have transparency without meetings, like what I think most of you are using a Slack to have instant communication about things. And for us, it's more like a Facebook effect. It's like I have friends in the US, and because I see their postings on Facebook, when I meet them, it's like I never been away. I know how their life went, and it's very good to have a system like that keeping you up to date. So it's actually working when you have a software that keeps you up to date with stuff like this. But still, in agile projects, most teams use black or whiteboards. So because it gives you a better overview when you have like cards on a wall and you can stand in front of it, and because computer screens are too small to show this same overview. But why is that? It would be much better if we could put this in a system and not having to bother about cards that maybe fall down and disappear onto a desk, which we had like in 2007. We had one card missing from a whiteboard, and we didn't know that, and we found it under the desk just before the expected delivery date. So we were panicking at that time. Yeah. And of course, you need to know who's working on what is done, what is not done. But you cannot go around and ask everybody, because it takes time, and it keeps people away from work. And of course, you have to take a look if everybody is really working on the planned story. So I have some anecdotal evidence from projects where I worked also with other teams from other companies, where all people worked on the stuff that was assigned to the sprint. But one guy was actually working on totally different things, and afterwards saying, yeah, but we need it anyway. So this is not really something where you can run a project. You have to also take care that you have the herd together. So, and of course, you also need transparency and communication to get the feeling of being part of a larger team. If you only work on your stories, you don't know the big picture, and you don't feel that attached to the project, I think. Last thing is, are there any problems? Are we spending an unusual amount of time somewhere? Are new developers getting up to speed? Are there any external factors we have to tackle? Is there a systematic under or overestimation? Should we look into something? Are we leaking time somewhere? And is there somebody in the team who needs support? I think one of the most important things is when you hire new programmers to really help them to get up to speed and learn lots of things, to get equal with the others on the team. And the question is also, is done really done? So you need feedback from the stakeholders. And if you have feedback from stakeholders, maybe you have changes, and then you have follow-up stories. And what will do this to your plan? So of course, what if an intelligent agent could do this for you? Let's talk about agent-based systems. It's actually Sean Connery. Maybe it's more like this what we're looking for. An intelligent agent is an autonomous entity which observes through sensors and acts upon an environment using actuators and directs its activity towards achieving goals. So we have a goal that we want to reach, like delivering a software, and we have sensors that gathering data, and we have actors that try to push the world or the environment to reach that goal. On Wikipedia, you see nice definitions about this. Here are different kinds of intelligent agents described, like a simple reflex model where you have like data coming in and you have just like if then else things, or you have more complex things that keep a state of the world and then have like conditions and actions. And then you have model-based things, goal-based things, where you really have attach a goal or several goals to the agent, and then it percepts the environment and tries to make sense of it and tries to push the environment in a different direction by applying actions. And sometimes you also want to, or most of the time you also want to examine the utility of what you're doing, not just pushing to an action, but also the side effects here that you're maybe creating when you're doing one kind of action. And of course, in the end, you want to have something that really learns from it. But in the beginning, you just have to start with a perception of the environment. Actually, there are already lots of intelligent agents in place, like Siri or Google Now or Facebook. In the beginning, Siri was more like that you had to ask Siri questions. Now, Siri is getting more interesting by reminding you on things. Google Now is very good in that. It's very small things that they are doing, but they are doing it quite good. And then we also have now Facebook in this space, integrating this into their messaging application. And this, I think, is also the future, that we will have like intelligent agents communicating with us over messaging technologies. Like everybody from you is maybe using Slack, and we are using it for communication. And can you see it here in our own company, where we have like a Slack channel where also the cloud monitoring from Google Compute Engine is pushing information into it so that everybody sees interesting information. And here's an example from one of the Slack bots on the market, which you can assign a task to ask questions to your team members, and the bot will ask these questions, gather the answer, collect them, and then give you the whole answers back. So it's also a way of making communication less time-consuming. And of course, I have an Apple Watch here. It's also the next step will be that we have watches included into this area, that we can use them as sensors, but also as actuators, talking with us and directing us in to the right goals. So here's what we have built. This is actually the application. I'm not quite sure if I now do the demos. No. So I will show videos in a couple of minutes. And what we actually did is we first built the application to run an agile project. So really gathering stories, epics and all this, making estimations, doing this work, and also entering data every day, the smallest amount as possible, because people should administering data all the time. It should be very easy to do. But we needed something to gather the data about the project in a very, very structured way. And then we started using game AI techniques on the server side and gathering this data from our teams in real time. And the basics we have to do before we can start learning with this data is actually, this is how we did it. We started with the data that we get from the world. Word is actually our Goethe tool currently. And the most important things are, of course, the target dates and the different sprints that we have, or milestones. Then the estimations we have for all the stories that are in the schedule. And then we just need the information from the developer, what is started. So what you're actually normally doing when you go to the whiteboard, you attach something to the whiteboard and say, this card, I'm working on this, and this is what we're doing in our system. And in the end, when you deliver something, like when you put a card into the delivered area, and then the acceptance area, when somebody is like doing code reviews and everything, this is also a state change that the developers are doing in the systems. And so we all get this data in real time over the sensors. And we have a state about the world. The project is actually the world there. And we have some goals that we want to reach to push this project to the goal. And we try to find out, we can program actions to inform developers, disseminate information and all this. We ask, or the system asks itself, what will it be like if I do action X? And we also check side effects, so the utility, so how happy I will be in such a state. And if we get to a good value, then we tell the actuators to actually execute this action and get in contact with the developers. To understand the difference between goals and utility is, for example, when you're playing a first-person shooter together with non-player characters in your team, and they have like the goal to get new bullets, and there's mags lying around there. So the goal would be for the NPC to reach out for the mags and for the ammunition. But if he gets killed on the way because bullets are flying around him, then the utility is very low when you directly die after it. So you always have to check not just reaching a goal, but also what kind of side effects you're maybe introducing. So, and there are several things how this is done in game AI. And one thing that is getting more and more traction is actually goal-oriented action planning in game AI. There's also some interesting books about AI and game technology. And there's also, like in the last Killzone title, they had also goal-oriented action planning with hierarchical bots, which is a really interesting concept. And I tried to do something very similar. Actually, the difference between a state machine and goal-oriented action planning is a state machine is very hardwired. So you have like state changes and the nodes in this graph, and this is very hardwired. And when you have lots and lots of actions, lots of state transitions, it gets it very, very difficult to maintain. And in goal-oriented action planning, you have like just loosely coupled goals and actions. So you don't have hard wiring between them, but you find out in real time, and depending on the current state, which action is the best suited one for reaching the goal. So to give you an example, I have this from a book called Artificial Intelligence for Games, 2nd edition, which is a very, good, very, very good book. To reach a goal, we can select the best next action that reduces high insistence values. So insistence means that some goal is really, really important. So for example, we have here the goal of the character saying, I have to eat. So number 4 is really, really high. I have to eat. And I have to go to the bathroom. So it's on 3, it's also really high. So when I do the action drink soda, it will decrease the goal eat by 2, but it will increase the goal bathroom by 3. So the insistence going higher that I have to go to the bathroom but don't have to eat anymore or that much. And if I execute the action visit bathroom, then it decreases by 4 the insistence value of bathroom. So if I check this, then of course it would be a no-brainer what you would do next. If you have like the high value on eat because it's higher than bathroom, then I would like to drink the soda, then I have eat -2, but bathroom is +6. So maybe it's not a very, very good side effect that I'm creating. So maybe it's much better to first visit the bathroom to get the bathroom insistence value low. And this is how you do it. Actually, if you're considering side effects, you're really calculating the discontentment value. So how unhappy would you be after executing that action? And here's the example again. And the discontentment is just calculated by calculating the insistence values and squaring them. So that like higher insistence values get higher discontentment. So and you can see here, like if I do the action drink soda, I have eat is 2 and bathroom is 5. So 2 squared is 4, 5 squared is 25. Add this together, it's 29. So the discontentment would be really, really high if I drink soda, but the discontentment is much lower when I visit bathroom. It's only 16. So I would then take this action. So what our hypothesis is that we can model our project world using the same methods. And of course, this is not a really intelligent system like humans are, and maybe this way of doing it is maybe never reaching this level. But when we play games, we really, most of the time, really like the game AI currently, how it works and operates. So we can learn lots of things from using game AI methods here. And if a character appears to be intelligent, then there's very much enough for us. So what we are doing is all aspects of this project are monitored by specialized software bots. So we spawn bots for different things. Like we spawn bots for one bot for every developer in a team. We spawn bot for each milestone or sprint. And we spawn a bot for the whole project. And we could also spawn bots for different other things that take care for a specific aspect and maybe also using their own algorithms. And then we have attached actions to these bots, and we have a planner to find out which action would be the next to execute. We have sensors in place that get real-time data from real-time databases, and then soon we will also have like commit logs from Git and all that we can push in the system. And we have actuators that reach out to the world and telling what would be the next action to do. And here we are using Slack and the Slack API, and it's all written in Go, and the Slack API in Go is also there. So what can we do? We have sensors like stories, progress, commits, bugs, calendar, or maybe even the Apple Watch that shows if you are in the office or not. Actuators like messengers, IRC, XMPP, again, the Apple Watch, or even text-to-speech to talk to people. Maybe not while they're programming, but maybe you can even call them on the phone and tell them things. And then we have different bots that we can imagine. So we have personal bots already, we have sprint milestone bots, we have project bots, but cool would be anomaly detection bots, pattern recognition, or network bots that learn, and also extra planning bots that give hints on how to change things. And of course, my favorite is having a code quality bot that really checks the code out and tries to measure the quality of the code. Actually, I implemented the backend in Go, which is a great language, and tomorrow in my talk I will do also some live coding if you're interested. And this is also in DSL I implemented for the project. You can see here several methods in the DSL to get all the data together, and these curly braces. The mustache syntax is just from the text template package from Go, which is delivered with Go, which is a really fine thing to render text, and we are using that to very, very fast create new actions. And in the future, it will be that the people who are using Goethe can really write new actions in the user interface and submit them to their project. So they have specialized bots and actions at their hand. So let's go to the demo videos. 8 minutes left. I'm quite good on time, I think. So here we have it. Full screen, 1 second. Where is it? Huh? First one? Ah, yeah. It's much better to see from the large screen, it's so small here. Okay. So this is Goethe. So you have it's a material design application written in React. You have here the priorities that you can use. You have users here. I'm just the only one in this demo project. And you have the states where you can give feedback to the system what is done and what is not done. We have several export possibilities. And this is like a tree. So you can write epics down from the top level, and you can like collapse the trees, and you can add child nodes to every node. So it can really work like in a really cool document editor, and everything can be done with keyboard shortcuts. So we have here's the help system. You can see that you can like do all the stuff with a keyboard. You can move stories around in the tree. You can move them a hierarchy up or down, or on the same level of other nodes. Everything with a keyboard, and you can create new stories by using keyboard shortcuts. And here's, I take one example. Yeah, I create a new story. Actually, we started using Bootstrap React. We're not super happy with it. We used then a special React framework for material design, which was not that stable. And I think now most of the time we use the CSS, material design CSS provided by Google. They have an extra project which is separated from the Polymer project. So I add some estimations here, like 15 to 25. It doesn't matter if it's days or points. You can assign a responsible person, and now I create the story. And now it's in this tree, and it's selected with a blue color. You can see it's new, and you can see now I'm moving it down. I'm moving it out on its own level. You can see my icon at the end. I'm attached to this story. And now I can add new features to it. I used Ctrl-Shift-P to add like first action that I want to build. And now it's like under this node. So it's I also often use this tool to work together with customers in the first meeting. So I really write it down, and you really don't have to talk later about minutes of meetings and everything, because you just write down what you want to achieve, and you can do it top down and bottom up and move things around. It's very, very fluid way of working. 4 minutes left. So I now do some more estimations. Now let's see if I can make it a bit moving forward. So here, moving around. Yeah, here. This is also interesting. So I'm now starting the story. So I with just a click of a button, the developer can now say, I'm now working on this story. And then you cannot change it anymore because you're working on it. But this is also one thing, and now the backend system already got in real time the information that somebody started the story. And he can also add progress, like a text. If he's working on something and he wants to get people know things about this, he just adds a progress record to the story, just maybe a little text like I'm doing here. And this is also then used as if we have a yesterday command, for example. You can also run all these actions not only in the intelligent agent, but you can also use them interactively. You can ask like for yesterday, and then you get all the stories that are worked on yesterday by the team, and these data is then used to provide this information. So this is quite cool. So then we only have 3 minutes left, but we're getting closer. Okay, this is this video, and now I have a second video. This is about Slack. So here I am inviting the bot. We call it 0 in the moment because it's the first version, but also it's so cool, that's why it's 0. Normally we should call it sub-0 because it's much cooler than that. Yeah, you can ask him questions. So you can, this is what I said, you can also execute the actions interactively. So you can ask for specific commands. You can get help. You can ask for what kind of bots are valuable, what kind of commands are they listening to. So even each bot could have different commands. So it's not like that all bots have the same commands. So here I ask for a project like the Betty project, and this is what the project bot understands. It's not done, planned, and yesterday. It's just a test system here. And now I can ask for a specific release at 0.22. And there I see now, if I say not done in 0.22, then I get information from the Slack bot, and this is just lists, so it's not that exciting, but this information is also sent to the people in real time. But this is actually the main problem. In a game, you normally have one action to do because this is then a character animation on the screen. But in our system, we can do many actions at the same time. But when we are doing them too often, people get annoyed. So this is a different problem than what you have in game AI. So here can ask for the plan from one of the project members. What is his current plan in his current project? So it's very, very simple command language here. And we will also increase this more and more, making it more useful and providing dynamic commands that you can edit in your own user interface. Okay, so this was a demo. So of course, we also think that it's so good, maybe we should also provide it to others. So if you are interested in it, you can sign up here for a closed beta. I'm not quite sure when we open it up, but we are already using it in production. So if you like it, go to goethe.instapage.com to sign up, and we will invite you for the closed beta. And I really love to have your feedback on that. And yeah, you can even send me an email, stefan@freiheit.com, Stefan with F. And if you like my talk, or if you have questions, you can always come up to me also with ideas. So we are very open with it and love to hear about the real world problems that you are encountering. So 11:45, this is really much on time. I didn't need an intelligent agent besides me to do that. So thank you very much. You can follow me on Twitter. My handle is SmartRevolution. And of course, we're always looking for people working for us. Thank you very much. Is there still room for questions? Yeah? Not really? Quick, is there anybody with question? I can't see anything. You have to yell, throw something. There's a guy. Huh. Okay, the question was, how do you feel how do your employees feel about the surveillance? Actually, we're building it together. It's not something that is like handed down from the organization. People have to do it. We're actually building stuff for ourselves, like we did in the last 15 years. We always try to improve how we are working, and if we spend too much time on organizing things, we need better tools. And better tools mean you need real-time data. And this is why actually everybody loves to have stuff like this, because it maximizes the time you take for programming. Something else? There's a guy. The question was, is the prioritization part also automatic or manually? Of course, it cannot be automatically, because prioritization lies in, this is something that humans have to do. But we add this as metadata, and we can also use it to reason about how to change the plan. If you know the importance of things and you know what stuff people already worked on, if you want to finish that first or want to push stuff more in the future. So we are actually using this information also to do the planning, but prioritization is done by humans. Sorry, I didn't understand that. No, I don't have something now which I can show. But yeah, drop me an email. Okay. Yes. Anything else? Okay. So yeah, thank you very much again, and see you tomorrow maybe in my talk, or this evening at the party. You can always come up to me and talk to me if you're interested. So, and of course, I like good ideas to make this better. Bye.